In this video, I will explain standing wave ratio. Standing wave ratio. A standing wave results from two waves having the same frequency and traveling in opposite directions on a transmission line. This is the original wave, original signal, that is blue color. Reflected signal is red color. Standing wave is the black color shown in figure. A standing wave results from two waves having the same frequencies. Two waves means original signal and a reflected signal having the same frequencies and traveling in opposite directions. Original signal is traveling from generator end to generator end to load, load end. That is the original signal movement. And the reflected signal is movement is from load towards the generator, from load to towards the generator. This one is a blue color signal. This one is a red color signal. Reflected signal is red color. Standing wave signal is blue, indicated by black color. The standing wave results from two waves having the same frequency and traveling in opposite directions on a transmission line. The meeting of these two waves produces a standing wave pattern of voltage and current on a transmission line. That is, the incident and the reflected waves will combine to form a standing wave. Blue color indicates incident wave and red color indicates reflected waves. These two waveforms are combined to form a standing wave on the transmission line. This one, when a signal is transmitted through the transmission line, some signal power is always reflected or returned to the source due to discontinuities in the transmission line. This is the incident wave indicated by blue color, and reflected wave is represented by red color. Some signal power is always reflected and returned to the source due to discontinuities in the transmission lines. The measurement of this reflected power is called as return loss. Return loss. The measure of this reflected power is called return loss. The return loss is expressed in dB. In ideal transmission line, where the load and source are perfectly matched, that means the load impedance is equal to characteristic impedance of the transmission line. That is called as a perfectly matched condition. All the power input from the source is delivered to the load. There is no wastage of that power. There is no return loss. In that ideal case conditions, ZL is equal to Z0. All the power input from the source is delivered to the load. However, practically, this is not possible. Ideal conditions are not possible as the load and source cannot be perfectly matched. That means ZL is not equal to Z0. There is always some level of mismatch. Some mismatch is there. This is the matched conditions. This one is a mismatch condition. This one is mismatch condition. This mismatch causes part of the signal to get reflected back from the load towards the source. This is the red color. The waveform, reflected waveform is indicated by red color. The voltages and currents of the forward and reflected waves in the transmission line add or subtract at different points according to the phases, thus creating a standing wave. Due to mismatch at the load side, some of the waves are reflected back and moving towards the source. The voltages and currents of the forward and reflected waves in the transmission line add, in some case add or subtract at different points according to the phases of the uh, reflected wave and incident waves, thus creating a standing waves. Voltage standing wave ratio VSWR is defined as the ratio of the maximum to the minimum voltage on a lossless line. It tells the severity of the standing waves in in a transmission line. Next one, voltage standing wave ratio. Two types of standing wave ratios are there: current standing wave ratio and the voltage standing wave ratio. First one is voltage standing wave ratio. The ratio of maximum voltage to the minimum voltage is called the voltage standing wave ratio. That is, voltage standing wave ratio is equal to the ratio of maximum voltage to the minimum 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 voltage. Minimum voltage is called as the voltage standing ratio. V maximum is the maximum voltage observed on the transmission line when the incident and the reflected voltage waves add in phase. Very important point here is V maximum. No doubt, this is the blue color waveform is called as incident wave, and the reflected wave is represented by red color. This one is the reflected wave. This one is reflected wave due to mismatch of the load. Okay, V maximum is the maximum voltage observed on the transmission when the incident and the reflected voltage waves add in phase. V maximum is the maximum voltage observed on the transmission line when the incident and the reflected voltages add in phase. Therefore, the maximum voltage along the line is given as V maximum is equal to V maximum voltage along the line is given as mod V plus. In phase means we use plus sign. Out of phase means we use minus sign. V mod V plus plus mod V minus. Generally, we know that Vs of Z is equal to V0 plus when Z is equal to L. When Z is equal to L, Vs of L is equal to V0 plus e power minus gamma L plus V0 minus e power gamma L. This one is the incident wave representation. Incident waveform representation. This one is reflected waveform representation. Reflected wave representation. This one is V plus, this one is V minus. Therefore, find out V maximum is equal to V max is equal to mod V plus means mod V0 plus e power minus gamma L. V minus means mod V0 minus e power gamma L. Mod V0 plus e power minus gamma L is the common term. 1 plus mod V0 minus e power gamma L by mod V0 plus e power minus gamma L. V mod V0 plus e power minus gamma L 1 plus mod of V0 minus e power gamma L by V0 plus e power minus gamma L. That is equal to mod of V0 plus e power minus gamma L 1 plus this is mod reflection coefficient tau L. This one is V maximum. This one is V maximum. Next V minimum. V minimum is the minimum voltage observed on the transmission line when the incident and reflected voltage waves add in opposite phase. Therefore, the minimum voltage along the line is V minimum is equal to mod V plus minus opposite phase means we use minus sign, mod V minus. Mod V plus is equal to incident waveform, that is V mod V0 plus e power minus gamma L minus V minus is V0 minus e power gamma L. Mod V0 plus e power minus gamma L is the common term. 1 plus mod V0 minus e power gamma L by V0 plus e power minus gamma L. This is the reflection coefficient. Mod V0 plus e power minus gamma L into 1 plus mod tau L reflection coefficient. This one is minus sign. Here we use minus sign. Here we use minus sign. This is V minimum. Voltage standing wave ratio is equal to V maximum by V minimum. V maximum is equal to mod V0 plus e power minus gamma L by into 1 plus mod tau L by mod V0 plus e power minus gamma L 1 minus mod tau L. These two are cancelled. For voltage standing wave ratio, VSWR is equal to 1 plus mod tau L by 1 minus mod tau L, where tau L is called as reflection coefficient. Reflection coefficient mod tau L is equal to VSWR minus 1 by VSWR plus 1. One more expression is tau L is equal to ZL minus Z0 by ZL plus Z0. For a matched transmission line, ZL is equal to Z0. Therefore, ZL is equal to Z0. Tau L is equal to ZL minus ZL by ZL plus ZL. 0 by 2ZL, that is equal to 0. Voltage standing wave ratio is equal to 1 plus mod tau L by 1 minus mod tau L, that is equal to 1 plus 0 by 1 minus 0, that is equal to 1. Voltage standing wave ratio is 1. VSWR is V maximum by V minimum is equal to 1. V maximum is equal to V minimum for matched loads. For matched load. For this condition, the standing wave pattern is simply a line representing constant value, representing a constant amplitude. Because V maximum is equal to V minimum. Second one is for an open load transmission line. For an open load transmission line, means ZL is equal to infinity. We know that tau L is equal to ZL minus Z0 by ZL plus Z0. ZL 1 minus Z0 by ZL. ZL into 1 plus Z0 by ZL. These two are cancelled. Therefore, tau L is equal to ZL is equal to infinity. Therefore, 1 minus 0 by 1 plus 0. The reflection coefficient is 1. Find out the standing wave ratio. VSWR is equal to 1 plus mod tau L by 1 minus mod tau L, that is equal to 1 plus mod 1 by 1 minus mod 1. 1 plus 1 by 1 minus 1, that is infinity. VSWR is V maximum by V minimum is equal to infinity for open circuited load condition. ZL is equal to infinity. Therefore, V minimum is equal to 0. V minimum is equal to 0. Therefore, standing wave pattern possesses perfect nulls because V minimum is equal to 0. The standing wave pattern possesses perfect nulls. Next one for a short circuit line. For a short circuit line, ZL is equal to 0. ZL is equal to 0 means tau L is equal to ZL minus Z0 by ZL plus Z0. 0 minus Z0 by 0 plus Z0, that is equal to minus 1. Voltage standing wave ratio is equal to 1 plus mod tau L by 1 minus mod tau L. 1 plus 1 by 1 minus 1, that is again infinity. From the above result, standing wave ratio, voltage standing wave ratio lies in between 1 and infinity, and reflection coefficient tau L lies in between 0 and 1. 0 and 1. Next one is current standing wave ratio. Current standing wave ratio. Current standing wave ratio. IS of Z is equal to, we know that I0 plus e power minus gamma Z plus I0 minus e power gamma Z. I0 plus is V0 plus by Z0 e power minus gamma Z. I0 minus is minus V0 minus Z0 e power gamma Z. IS of Z is equal to L. IS of L is equal to V0 plus by Z0 e power minus gamma Z, gamma L plus minus V0 minus by Z0 e power gamma L. IS of L, Z is equal to me L. This one is incident wave. Incident wave. This one is reflected wave. Reflected wave. This one is I plus, this one is I minus. I maximum. Similarly, in case of V maximum, I maximum is the maximum current observed on the transmission line when the incident and reflected current waves are add in phase. This one is incident wave, current wave. This one is reflected current wave. These two are in add in phase, means we use plus sign. I mod I plus plus mod I minus. Mod I plus is V0 plus by mod V0 plus by Z0 e power minus gamma L plus I minus is minus V0 minus by Z0 e power gamma L. Mod minus X is mod X, that is V0 plus by Z0 e power minus gamma L plus V0 minus Z0 e power gamma L. E power gamma L. Common term is here. V0 plus by Z0 e power minus gamma L. This one is common term. 1 plus mod V0 minus Z0 e power gamma L by mod V0 plus by Z0 e power minus gamma L. That is mod V0 plus by Z0 e power minus gamma L 1 plus mod V0 minus e power gamma L by mod Z0 mod Z0 by mod V0 plus e power minus gamma L. These two are cancelled. V0 plus by mod V0 plus by Z0 e power minus gamma L 1 plus mod V0 minus e power gamma L by mod V0 plus e power gamma L is mod reflection coefficient 1 plus tau L. Similarly, in case of I minimum is equal to I minimum is the minimum current observed on the transmission line when the incident and the reflected current waves are add in opposite phase. That is mod I plus and mod I minus. That is mod I plus common term 1 minus mod I minus by mod I plus. Mod I plus is I plus is V0 plus by Z naught e power minus gamma L. V0 plus e power minus gamma L by Z naught into 1 minus V0 minus by Z naught e power gamma L by V0 plus by Z naught e power minus gamma L. Finally, we'll get V0 minus e power gamma L by V0 plus e power minus gamma L, here gamma L, that is equal to mod V0 plus e power minus gamma L by Z naught into 1 minus mod tau L. This one is I minimum. Current standing wave ratio is equal to I maximum by I minimum. I maximum is V0 plus e power minus gamma L by mod Z naught 1 plus mod tau L by V0 plus e power minus gamma L by Z naught 1 minus mod tau L. Therefore, current standing wave ratio is equal to 1 plus mod tau L by 1 minus mod tau L. Voltage is same as voltage standing wave ratio. Current standing wave ratio is same as the voltage standing wave ratio. With this, the analysis is complete.